Welcome everybody to AI Horizon. So it looks like we have people are still funneling in, but we're going to go ahead and get started today. So today's agenda, we have two fantastic speakers. But before we get to them, I have a few quick announcements. And a lot of these you probably already heard. Some of them might be new to some of you. So I'm just going to copy in some links to chat here. Okay, so the first announcement is the TLT Symposium. So that is coming up on Saturday, March 22nd. So that is free to attend. It will be at the Penn Stater and we will feed you. So breakfast and lunch. So come hang out with us. We have some fantastic presentations. A lot of them are AI themed this year, not all of them, but so if you're interested in pushing your learning with AI, come hang out with us on Saturday, March 22nd. And then about 2 or 3 weeks later, Penn State is hosting AI Week. And by Penn State, I mean the AI Hub is assembling this with a bunch of fantastic presentations across the university. So I put the link there in chat. We have a few presentations in there. We will be hosting Can AI Play, and we are launching our newest experience here in TLT called Can AI Game. So not to give too much away, but you will be using AI to code a game. And that's all I'll say about that. But if you want to, we have a registration link on the AI Hub's website. Register for that and come hang out with us for that one. And the last announcement we have is the Dreamery Speaker Series, which will be during AI Week. So this will be April 15th here in the Dreamery. You can register through the link that I posted in chat. You can attend that online, but there will be a big in-person presence here with Dr. C. Edward Watson, who will be presenting on teaching with AI. So that will be on April 15th. Ooh, Griff chocolate cake. I'm not sure if we'll have chocolate cake on the menu this year, but I hope we do as well. Okay, so that is all the announcements I have. And now I'm going to introduce our first presenter, which is going to be Andy Gatto. He is an innovation ecosystem and partnership strategist with the Nittany AI Alliance. And today he's going to be talking more. He's going to be sharing what the Nittany AI Alliance is, and if you have students who want to get involved, he will share some opportunities to for students to be involved with the Nittany AI Alliance. So without further ado, I'm going to kick it over to Andy.
Awesome. Thank you. I appreciate the intro, and I always chuckle when I hear that title. It's definitely in that category of like, hey, can I make up a title that captures all sorts of stuff that I do and not really do that great of a job? So really, I'm our partnerships guy. So I look for ways to bring resources and folks together to execute the programs we run. So that's a fancy title to explain that. But let me share my screen. What I'm going to do is just take a few minutes today to describe, talk through who we are as the Nittany AI Alliance and what we do, and then talk about some ways that we can work together to kind of bring this Horizons community that you all have developed together with our Nittany AI community. So I'm going to go ahead and share my screen. Start my show. Okay, so hopefully everybody can see that screen there. So Nittany AI, who are we? So the Alliance it's kind of we've evolved over, I would say, it's been about probably 9 years now, where we started back. It was kind of the brainchild of Craig Weideman when he was running outreach in the World Campus, and Craig connected with Darren Kudre, who is the current director of Nittany AI. And it started as the EdTech Network. We were closely aligned with the World Campus back then, evolved into becoming Nittany AI as we focused in on this rapidly evolving technology back then. And now, fast forward to this semester, we have kind of taken our latest evolution and joined the College of IST to bring the community we've built and these experiential learning opportunities to the college. So what we're really focused on is this collaborative ecosystem of students, faculty, staff, and industry partners, and developing experiential learning projects focused on real world problems. So we are really looking at how can AI be applied to real world use cases and giving students an opportunity to build on this kind of foundational knowledge that they're getting in the classroom, and develop some really career oriented skills. So we really see ourselves as the connection, between the class and the academic environment to what's happening out there in industry. And we find that to be incredibly important in the AI space because of how rapidly everything is moving, how quickly the technology is advancing, how quickly different applications and use cases are surfacing. And so we try to stay really connected to that outside world, so to speak, as we develop the types of projects that our students are working on. So as we pull together this community of stakeholders, we're really focused on making sure we're delivering value to everybody, because you're not going to have a sustainable community if you can't deliver value to the folks that you're working with. So if we look through the stakeholders and the types of people we're working with, students are obviously at the core of everything we do. So we're trying to provide these really unique and engaging experiences that are tangible for the students, that they can walk away feeling like they have developed skills that are going to be helpful as they go forward into their careers, that are going to give them, stories to tell and a narrative to work through as they're going into the interview process. And it's really with this idea that AI is everywhere. AI is going to impact you no matter what college you're in, what degree you're studying, where you think you're going to go work when you leave Penn State. AI is really become this horizontal that is kind of ubiquitous across all industries. So gaining that experience, whether you're in the College of Ed or whether you're, comp sci or IST, or you're in the College of Medicine, wherever you are, gaining experience working with AI is critically important. So we want to provide students from across Penn State with those experiences. Nonprofit partners in Penn State really have become a focus as far as the folks that we're working with to identify problems and ideas and challenges, so that we can, there's this knowledge transfer that occurs between our student teams working on projects and the partners that we have involved. So we started out early, really focused on nonprofit partners. So we were bringing in funding from industry to execute these projects with nonprofits from all different areas. And we've kind of evolved and seen the value we can provide back to the university as a bit of an innovation engine, looking for opportunities to transform Penn State and to apply AI across business units and work with faculty in classrooms. So that's something we've really leaned into over the last couple of cycles of our program, and we're starting to see some really nice success there. So faculty and industry, as we go down the list, faculty and industry, the collaborations there and the value back to our faculty partners is really to help build relationships with industry, stay connected to what's going on in industry, to leverage the work that's happening in the projects and the innovation that's surfacing from students and our partners to seed research ideas, to maybe help advance some research initiatives that faculty are working on, because we've had faculty bring project ideas to us. And then from an industry standpoint, the value there is really it's this strategic process for connecting to top talent at Penn State from a recruiting standpoint. So industry is, there's a lot of competition in the space right now for AI talent. It's a really interesting time in the career market right now, in the job space. So it's constantly evolving, but we try to stay closely connected with industry to understand their needs, the types of skill sets they're looking to hire. And then we're working with them to design projects that really highlight those skill sets and surface talent that they can bring on board. And there's a quote there at the bottom. Alan Pye is a partner of ours from Lockheed. Lockheed's worked with us for a number of years. And he's the person who we kind of stole that term from, a strategic process for recruiting top talent. So all of this is built around this funnel that we talk about all the time. We call it a funnel. It's our innovation framework. So these are the kind of the four legs to our stool. So at the top of our funnel is what we call Nittany AI Inspire, and that's really all of the events that we run. The broadest part of our funnel to pull in students from across the university into the program, and then and I'll touch on each of these in a little bit more detail. And then we go down from there into the challenge, which is the open innovation competition, Advance, which is our more focused internship model, and then Connect is the way that we stay connected to our alumni. So let me talk quickly about Inspire. So AI Inspire, like I said, the top of our funnel. Really, this is kind of event-based. So this is the goal here is to reach as many students from across Penn State, the whole Penn State ecosystem as we possibly can. So we have faculty partners across different campuses as well who we've worked with over the years. So we have some really great relationships at Berks and Great Valley, and other campuses where we consistently have students engaged. But really, this is our way to reach students, give everybody a little bit of experience with AI, kind of get that message across that AI is everywhere and that you're not going to get away from this technology. So you might as well lean into it and start to gain some experience. So this includes things like what we're doing today. In the fall, at the beginning of our Nittany AI Challenge cycle, we run a lot of workshops around idea discovery. So how do we host these different ideation sessions to surface unique and interesting use cases and challenges where students can apply AI. Because what we found in the past when we weren't really focusing on that ideation segment of what we do, that we started to get a lot of repeat ideas because students are just looking at it, they're kind of have their blinders on and are in their worlds and looking at things that are challenging to them, around course scheduling and finding apartments and, issues with roommates and things like that. And so we actually created these pillars or these focus areas. And so now we try to host these ideation sessions to drive, pull in more ideas, to drive innovations and kind of diversify the types of ideas that we're getting into the challenge, into our ecosystem. We work closely and help to start and found the Nittany AI Student Society, and they are an incredible group of students who does a lot to help us get our events out there and to bridge gaps to students across Penn State. They're doing some really cool stuff with a leadership academy that's focused on more non-technical students to help pull them into the AI space. They're doing some really cool things with ML Bootcamp that they run. So really a fantastic group of students who we work really closely with at the top of the funnel, again, to kind of pull folks into the ecosystem. And then classroom collaborations, which is something I'll talk about towards the end, but we're always looking for ways to get into the classroom with faculty, talk about what we do, look for creative ways to get students engaged, and then kind of, give them an on-ramp into our world. So next part of the funnel is the challenge. So hopefully the Inspire events are engaging enough and give students a taste of what we're doing and get them excited about the prospects of AI, and they get excited, and then we can pull them into what tends to be the first stop with us is the AI challenge. So open innovation competition, open to all students from across Penn State. It's really, hey, pick something that you're passionate about and develop a prototype AI solution. We provide a lot of support, so we run workshops on all sorts of different skill sets and AI tools. We run team formation workshops. We run those ideation sessions that I talked about. So we try to have this underlying support network for students entering the challenge to give them everything they need to be successful. The challenge is broken up into phases. So there's the idea phase where students have to present kind of an initial prototype, and we whittle that down because we get a lot of initial submissions that are just not up to par. And so we whittle those down in the prototype phase, and students continue to work through and build that prototype. And then as part of AI Week, so that Monday of AI Week on April 14th will be the conclusion of the AI Challenge, where the teams that have made it through all of the different gates and barriers, or not barriers, but the different gates and filters, so to speak, to get to that final competition will be on stage in front of an audience of faculty, staff, and industry judges, demoing and kind of pitching their solution for the chance to win some awards and win some prizes. So and a cool thing I'll mention that we do with the challenge that we only started doing a few cycles ago, but as we go through and we say, okay, these 15 teams are going to go on, the teams who didn't get some of that prize money to continue building are able to stay in the competition. So we've had teams kind of battle their way back into the competition and make it on stage and actually win prize money and awards at the end of the competition. So I love that aspect because I think it shows some grit and determination from those teams that are able to kind of battle their way back into the competition. So some of the highlights there, it's, we really see pretty cool diverse teams form. Students that may be the subject matter expert from ag who've never worked with ML or never worked with Gen AI. They come together with some of the more technical students and form really cool teams. Yeah, people from all levels of experience around the university, we see them in the competition. And it's a really great career development opportunity. Whether you win or not, to be able to tell that story of working your way through this type of competition is really pretty cool. So these are some of the prototype teams that are working right now in these last few weeks up until April 14th. So I just kind of grabbed a few off of the list to share, and so you could see the variety of solutions that we have teams working on. So this team obviously focused on issues that our advising staff here at Penn State probably see quite a bit. There's an application in the health space, healthy food choices. Interesting one, here with support for caregivers and Alzheimer's patients. But there's a wide variety. So I think we have 15 teams, if I'm remembering correctly, who are advancing and hopefully make it to the stage on April 14th. So there will be some information that we'll push out around that. The space is limited where we are, but we hope to be able to open that up and invite a bunch of folks to come out and kind of celebrate with us that evening after the competition. So from the challenge, we kind of whittled down a little bit more into Nittany AI Advance. So one of the things the challenge does is surface the rock stars, so to speak, who the top talent is in the space from an undergraduate student perspective. And we hire those students on as interns to work directly with us on specific projects that we have scoped out with our partners. So this is kind of if you're working through this in tiers, this is the top AI talent, working specifically with us to build proof of concept / prototype solutions that we've scoped out with our partners. So these are paid internships. They are typically scoped at 1 to 2 semesters in length. We work in an agile development structure, so there's about 6 sprints throughout the semester. Our staff at Nittany manages the project, so we kind of try to take that overhead burden off of our partners, and we really manage the students through the process. But they meet with the clients. This is a very client-facing experience for the students. So this is the most real-world example that these students get working with us. They're kind of thrown into the deep end and get to see what it would be like to be out there working with the client, consulting with them on their problem, understanding the issues, identifying the data needs, working through the AI tools that might be applicable, and then starting to build that solution and meet with the client on a biweekly basis and take the feedback and pivot and adjust as they go through. So it's a pretty incredible experience for the students that participate in this. Yeah, I think I hit all the program highlights there. So an idea of some of the partners that we worked with in advance. So it's really a mix. So this is where the industry partners come into play. These projects have been, for the most part, funded by industry. We've been awarded some grants along the way. There's been some internal dollars put in from our Penn State partners who are starting to look at where our student teams can help them explore AI use cases. So we're currently working with academic advising. We worked with admissions in the past. We're doing some neat stuff with faculty who's part of Penn State Extension. We're currently working with OPP. Lockheed's been a partner for many, many years and done a whole variety of projects with us. This semester, they have students looking at the application of physics-informed neural networks, so PINs, on modeling virus spread. The Farm Bureau has worked with us, and they have kind of had us look at this project around crop damage caused by deer in Pennsylvania, which is a massive issue. And there's a lot of dispute over the type of data, between the Game Commission and farmers over how many deer there actually are out there damaging crops. And so we're looking at some computer vision applications there and have been working with them. This will be the second semester we're working with them. We worked with the Red Cross a couple semesters ago now on how can we create a predictive model to show them where the optimum location is to host a blood drive. IBM worked with us on hurricane prediction, and World Hope International is a nonprofit that we did some interesting work with in Southeast Asia around survivors of sexual abuse and helping to train the folks that were working with those survivors. So really a wide swath of projects that come our way. And the last piece here, which actually, as I look at this model, this image rather, it should broaden back out because Connect is our alumni. So that's all of our program alumni who we stay connected to and tied into to be able to, pull back recent grads to be coaches to teams in the challenge, or to have them come back and run a workshop for our students or engage with the student society in some way. So truly, if this graphic was representative, it would get really broad there because we have a lot of alumni that stay connected, which makes us feel good because we think, that means they had a great experience with us, so they're willing to come back and do things with us. So, so that's me talking really quickly through who we are and what we do. But I think that the piece that is probably most important in a conversation like this is, so what? So how can we collaborate? Like how can we bring the AI Horizons community together with Nittany AI and do some cool stuff? So it really comes down to kind of four general ideas. So one is ideas. How do we get connected to you all and talk about challenges and opportunities you see in your day to day? Within your different worlds at Penn State. I kind of clicked through quickly to look at everybody's boxes and see whose names and faces I might recognize. But whether we're talking about things happening in the classroom, whether we're talking about operational efficiencies, any opportunities you all may see out there where if there's available data, then there's almost certainly an AI use case. I always joke with folks, I don't know. I have a really hard time thinking of an industry or an area where we can't find some sort of application for AI. So there's a couple ways we can do this. The simplest and most straightforward way is just shoot me an email. Like, let's get together and talk. I would love to meet with as many of you as possible and think through what opportunities might be out there for us to work together. We take a really consultative approach at Nittany AI to looking at what might make sense. Maybe it's we're bringing you into an ideation session for the challenge, and we're kind of sprinkling a whole bunch of little idea seeds around to a bunch of challenge groups and seeing what happens. Or maybe you're to the point where you have a really specific idea that we can scope out, and it is a fit with AI Advanced. So we'll work with you guys to figure out what makes the most sense there. And stay tuned on the ideation sessions. We probably in the next couple of weeks will be putting up on our event site some of the dates that we plan to host those sessions, because I would love to see as many of you all as possible in those sessions. It's a really cool way to bring together faculty, staff with our students, and roll up your sleeves and really kind of think about where AI can be applied. So that we've seen some really cool ideas come out of those sessions, and they're always a lot of fun. Just getting to put our heads together and work through where AI can be applied. So surfacing ideas is I think one of the low-hanging fruit opportunities for us to work together. Students is another one. We want to reach as many students as possible, pull as many students into what we're doing as possible. And one of the best ways to do that, obviously, is getting into the classroom with you guys. That's taken many kind of shapes and forms over the years. Two examples that I can give a shout out to is right now I've been working with Jacob Holster. He reached out. He's running a class. I think he said it was the second time through where they're looking at impact-focused ideas in the application of AI. So his class tends to be folks who've not really worked with AI that much. They're kind of more novice users of AI. This is their first time cutting their teeth with the technologies. And so the idea we've put together is we're going to pull some of the students in from Nittany AI to kind of come into the class and act as AI consultants for a day and work through, kind of hear what his students are working on in their projects and give feedback and give ideas. So I think that's a really neat way to bring our two worlds together. And hopefully the outcomes we could drive from that are, if one or two or three of those students in his class get excited, maybe build a relationship with one of the Nittany AI kids in the class, and they decide to take their idea into the Nittany AI challenge. I think that would be a massive win coming out of that. And then Chris in his class, IST 130, Darren went into that class last semester. It's a large kind of forum class. and Darren gave kind of a presentation on Nittany AI. So I think it was mostly focused on, how can you take what you're learning in Chris's class and apply it to the things that we're doing in the AI challenge, kind of accelerate your journey in the AI space by coming and getting involved with Nittany AI. So, and I'm sure there are a dozen other ideas we could come up with for cool things we could do together in the classroom, but that's another one. If you just reach out, we can think about how to do those types of things to pull students into the ecosystem. And then you all as subject matter experts are important too. We often have coaches on our chat working with our challenge teams, bringing some of that expertise around whatever it might be, food preservation or deer behaviors or whatever the expertise may be. We have a lot of students who know a lot about AI. The subject matter where that AI may be being applied is something where they could use some guidance from some subject matter experts. So we've tended to look towards faculty and grad students to help us out there. So that's always an opportunity to get engaged. And then creative partnerships. I can't think of too many times we've said no to sitting down and talking about ways to work together. And a recent example was the Center for Socially Responsible AI. Darren and Shyam and I sat down and talked about what we could do to work more closely together. And then we're cooking up some ideas to kind of what we had always done in the past was try to push our ideas uphill to faculty to get them excited about what we were working on. And Shyam said, why don't we flip that script around and look at faculty who've been awarded some of this CSR AI seed grants and see if we might be able to work backwards and look at ways to form AI advanced project ideas from some of the seed grant opportunities that already exist out there. So I use that example to say we're open to think through other ways to get engaged with our community and to work with you guys. So I think that's the what I wanted to cover. And I don't know, Zach, if we were going to leave time for questions, but I'm open to field any questions or to end there. And I'll put I imagine, Zach, you have my email somewhere for everybody, but I was going to throw a QR code in here, but I figured it's just as easy to capture my email and just shoot me a quick note if you want to connect and talk more about any of these things. So thank you.
Cool, thank you. I think we might have time for one or two questions. I can kick things off. I have a question. Well, it's not from me, it's from Chris Millay, who posted in our team space. But it's very relevant to your presentation, I think. He asked if any of you, so he's talking to the whole community, but I think it's very relevant to your presentation. Do any of you have examples of how industry-specific applications of AI are being introduced in instruction? So I know you had a lot of examples of industry-specific projects. I wonder, do you have any examples of any instruction integrations of how those industry applications are being introduced to students in their disciplines that is not IST in computer science?
If that's questions for me, I don't know. I don't know. There are so many different courses popping up that I have heard of with AI as a part of the curriculum that it's hard to keep up. So I don't know what's happening in all of the different classes out there and how folks are connecting to industry. It's a question I know I've asked and I've heard Darren ask a lot when we're in conversation with faculty is what are their plans to be able to keep up? Because I think that's probably the biggest challenge anyone building AI into curriculum is going to face is how do you keep it evergreen when things are changing on a daily basis? I mean, that was when Jacob Holster and I were meeting last week. That I asked him that, and he said, "I'm just going to have to refresh constantly because it is changing so quickly right now that I think it's really kind of distilling down to what are those foundational core skills that students will need to have, and one of them is just going to have to be an understanding that it's consistent learning, consistent adaptation is going to have to be built into anything you do with AI because it's unbelievable how quickly it changes. I'm sure you guys are all on different daily emails that you get, and every single one I see, it's version 3.5. Now it's version 3.7. This new one's just, DeepSeek's out. Now we have AI agents. It's just wild how quickly things are changing. So it's a massive challenge. And how do you develop curriculum that's going to stay up to date?
Awesome. Thank you. Well, if there are no other questions, we're going to switch to part 2 of our agenda for today. So our second presenter, we have Dr. Becky Passonneau, Professor of Computer Science. And today she's going to be talking about an ecosystem, an AI ecosystem for assessing statistics reasoning questions. So Dr. Becky, it's your show to take over.
Okay. So thank you very much for this opportunity. And it was fortuitous for me that Andy was presenting right before this because I'm very aware of Nittany AI. I've had a lot of students who participated. I teach AI to undergraduates, and I always post the announcements, and they often get involved in those things. But I didn't really have a clear picture of exactly what Nittany AI is, other than these challenges for students. So it was really interesting to hear about all that. So let me get ready to share my screen. Here we go. Okay, let's see now. It's not moving. I'm going to stop sharing and then just try that again. Okay, back to the first slide. And share again. Maybe I'll just do a slideshow. Maybe that. Oh, there we go. Okay. So it was expecting a different way of advancing. You'd think I'd know how to do this by now. And it's just going through the whole slideshow. So let me try one more time. Full screen, now that I know how to advance the slides. Why is it not doing that? Yikes. I've never had this happen before. It's really acting very wacky. I'm just going to leave it like this. Maybe I'll get rid of the sidebar, and then that way I think I can really control it much better. Okay, so this work, now that I'm getting started talking about it, is about research on how to use AI in education. And I've been working in this area, among other things that I do for a while. My area is natural language processing. But I've been very interested for quite a while in applying natural language processing methods to assessment of student writing for STEM education. So here are the people that are involved in this project that I'll be talking about today that was supported by NSF as an IUSC project that is going to be coming to an end soon. So who are we? Well, I got my doctorate in linguistics, actually, but right away I was working in AI because the questions I was looking at in linguistics were very much about the context of language use, which was much closer to AI than to linguistics. And as I said, one of my current interests is applying AI to education, but especially formative assessment. So I mentioned applying NLP to student writing, but I'm interested in formative assessment, which for some of you who may not be aware of the term, formative assessment happens while students are actually learning some material and going through learning objectives to get intermittent feedbacks to help them assess where they are and to help the instructor assess where individual students are and where the whole class is. The second person listed here is Yu Chen Wei, who's a master's student who's been working with me only since last fall. He took my NLP class the previous spring, and he's done a lot of the work that I'm going to be talking about today, apart from the data collection. Then the two people in statistics education are Matt Beckman, and I'll be talking about a data set that he collected as part of his thesis research back in 2015. And then Dennis Pearl, who's a retired professor. Matt is now the director of CAUSE, the Consortium for the Advancement of Undergraduate Statistics Education, following upon Dennis, who is the first director. And Dennis is also an expert in acronyms. So he came up with this acronym CAUSE, and you'll see another acronym of his soon. So the way I'm going to lay out this talk is first I'll present the motivation for the whole effort. Then I'll talk about two data sets that have some strong similarities, but also some interesting differences. And then I'll talk about this progression of automated formative assessment, where I'll start out by talking about the trade-offs between supervised methods to learn how to do this assessment automatically versus unsupervised methods, which means using large language models. And so then I'll talk in a little bit more detail about each of these two methods, and then finally how they can work together to reduce some of the trade-offs between the two. So what would be the point of automated support? Well, I've listed some of those here. First of all, many instructors are more interested in using open-ended questions instead of multiple choice questions. There's a lot of debate in the literature in education on whether multiple choice questions or open-ended questions are better and what the strengths of each are. But for open-ended questions, many instructors like them because it places more demands on the students' critical thinking and their ability to communicate how they're thinking. And that also means that then it gives the instructor more fine-grained understanding of student ability and student understanding of the concepts. However, it works best, formative assessment works best when the feedback is timely, so that it can be acted on pretty soon after the assessment has happened. Another reason for automated support is to address equity. So it can allow instructors of large classrooms that have, around 100 students or more to provide feedback to students that's comparable to the feedback that students would get in small liberal arts classrooms. It can also reduce the potential for the instructor to have biases based on irrelevant factors about, say, students who talk a lot in the class or who they happen to know well by working with them outside of class or whatever. And then also people in my area are very interested in developing methods that are not biased by differences in the usage of the language. And you'll see in a moment how we've tried to have one of these data sets actually have some systematic differences in usage so that students will be assessed only on how they know, what they know about the concepts, not about the quality of their English usage. So now let me start introducing the data sets by giving you a preview of what is in the data set. What is the data set for us? Well, first of all, the data set would have statistics reasoning questions for undergraduates of diverse formats. So one type of format that is used a lot is to have a little paragraph scenario followed by one or two or maybe even 3 or 4 questions about that scenario, or multi-sentence questions that kind of set up a yes/no answer and then ask for an explanation. Then along with the questions, there are assessment rubrics that are detailed criteria for these 3 categories that are used in these 2 data sets. And these rubrics are meant to be used by humans doing the assessment. So keep that in mind. The 3 levels of assessment are the student's answer is essentially correct, partially correct or incorrect. And I'll actually show you some examples. And then we have model answers for each of these classes usually. And then we have all the student answers. And finally, one of the most costly things to acquire in creating these data sets is reliable assessment labels. They have to be reliable to train the supervised models, because if they're not, then how can the models learn an appropriate label for a given student response? So the first data set is called iStudio, Introductory Statistics Transfer of Understanding and Discernment Outcomes. Now this was from Matt Beckman's thesis back in 2015. It had 12 tasks with about 20,000 responses from undergraduates all over the US. He had validated this instrument, and it was designed for research purposes, not for instruction in the classroom. It was the data was collected before ChatGPT, so all the responses were assumed to be generated by students. The subset that I'll be talking about here that we could call the AI subset is just 3 of these tasks that have a scenario and 2 questions with it, so a total of 6 questions. And we have 6,532 student responses from these undergraduates that are very diverse from all over the country. We added these labels for the assessment for this AI subset in 2019 and 2020 using 3 very expert annotators in statistics, labelers in statistics, and the agreement scores, quadratic weighted kappa, were different for each of the 3 pairs, but they were around 0.8 or above for all these pairs, so very high agreement. So to sum up, a research instrument data set with high label quality, and let's take a look at it really quickly. So here's a scenario. I'm not going to read all of this, so don't worry, but the scenario is about how somebody might test, a music teacher might test whether a student, let's call her Carla, has a good ear. And picking the 7 notes of the scale and then playing one at random on the piano, the student is asked to name what that note was without being able to see the piano or the instructor. And so the question is, explain how you would decide whether that student has a good ear for music using this method of note identification. And a correct answer might be, you could run a number of these tests, construct a 95% confidence interval about the number of notes she gets right. So the rubric defines what the criteria are for labeling a student response as essentially correct. And that means that the student has to name or paraphrase one of a long list of procedures that I didn't actually put here that's an appropriate inferential method. The answer would be partially correct if the student does one of these 2 things of recommending a conclusion based on a point estimate like a probability, or naming or paraphrasing an inferential method, but it's not an appropriate one here. So the student knows that you need to use statistical inference, but doesn't quite know the right method. And then there's the incorrect, none of the above. The next data set classifies, and here's another example of Dennis's skill at acronyms, common language assessment in studying statistics with instructional feedback and increased enrollment scalability. We have the participation of, besides Penn State, 5 other institutions, 2 of which are Hispanic serving institutions. And in this way, we have some of the data that we know come from students where there's a certain likelihood that the individual comes from a background where they've been exposed to Spanish speakers, maybe they're bilingual, and so on. The project started in 2023, and so we've actually tested using classifiers designed for this purpose, how many of the responses were created by the students versus generative AI like ChatGPT, and we estimate about 25%. Now, these tools are not perfect, so it assigns a 5% probability that the iStudio students might have used generative AI, which they did not have access to. So this 25% is sort of adjusted to account for a little bit of inaccuracy or uncertainty in the ability to identify whether something was human generated or AI generated. The subset that I'll be talking about here is only part of the full set that we're collecting. So we're collecting 19 tasks and 44,000 student responses. But here I'll be reporting on a subset that has 8 questions or tasks with 5,819 responses, and only 2 of the institutions, Penn State and Iowa State. The labels here were added by trained undergraduates last summer, and their inter-rater agreement using QWK is about between 65.65 and 0.70, depending on the pair of labelers. And so this data set differs in that it has some proportion of AI-generated responses. And also, the questions are not from a research instrument. They're more like in the wild. They're the questions that these instructors who are our partners at these other institutions would use in their classrooms. And the label quality is not quite as high as for iStudio. So those are our 2 data sets. And let me finish up the data sets by telling you a little bit more about classifies. Here's a question about trying to predict whether in a certain region, what's the percentage of students who are obese based on fruit consumption? And there's a correct answer, and the rubric says that the response is essentially correct if the student response has the following 3 components: names the 2 variables, which is explanatory, which is response, and indicates that the explanatory variable either predicts or explains the response variable. Otherwise, some of those, if it satisfies the first or the second component or both, then it's only partially correct and incorrect otherwise. So now I'll turn to the trade-offs between the 2 methods that we use for automating the assessment. So I've got these columns labeled PLM for pre-trained language model, where we use a pre-trained language model that's smaller than what we call these large language models with generative capability that have become very widespread. So pre-trained language model, where we add a classifier layer on top and turn it into a classifier so that it can classify the correctness of the student responses, and that requires a lot of training data. And then there's the LLM, and then there's our method that kind of has these 2 methods in a little ecosystem. So the PLM, well, all of the methods need at least a small test data set so we can evaluate how well they're doing. That needs to have all those components that I mentioned, and especially the labels assigned with some known quality to the labels. And the LLM and our joint method avoids reliance on a very large training set, but a pre-trained language model needs to be fine-tuned to the data, and it needs a training data set. And we have, for both data sets, about 5,000 to 6,000. The PLM does not generalize across domains for if you have a different STEM area or even a different part of statistics, you need to retrain with a new data set. But with a large language model and this cooperative method, you don't need to have all that training data because it already generalizes across domains. And high accuracy, without actually needing to rely on the rubric as input, the PLM, even though it's more costly to use and to train, actually can reach very high accuracy and perform as well as the best humans. However, it doesn't make use of the knowledge that's in the rubric. It makes use of the knowledge in, well, I'll actually be showing you what it makes use of in a moment. The large language model doesn't get quite as high accuracy. So you can see there's this trade-off between, well, the large language model is there, it doesn't need to be trained, it generalizes across domains, but the accuracy is not that great. But another advantage that would be nice to be able to exploit that a large language model can provide potentially that a PLM cannot provide is a meaningful explanation of the assessment label. Okay, so you got it partially correct, and here's why. maybe that could be done. I might say a little bit more about that towards the end. So here's a table showing the results of taking a particular pre-trained language model called Longformer that we're using because Longformer can handle, suggested by the name, input that's a very long span of text. So here what we're showing is that we used Longformer by adding a classification layer on top and provided different input: the question, the answer, the model, and the rubric, or the question, the answer, and the model answer, or the student answer and the model answer only. And the accuracies are all kind of similar. The rubric version actually for iStudio does a little bit better than the other two versions, but not by a whole lot. So it's not really exploiting the knowledge in the rubric very much. And for classifies, it only needs the student answer and the model answer to get its best performance. So now I'm going to turn to using unsupervised large language models, and we use GPT-4o Mini, which is very high quality, and also because it's small, it's more efficient to use, and so we can get this work done faster and less expensive with lower cost. And so here what we're doing is showing for each bar that's a different color, a different type of prompt that we provided to the large language model. And you can see that for this table, I'm actually showing 5 data sets, but we're going to focus on the 2 iStudio and classifieds. And the first 2 data sets did not have rubrics, so they don't have that last pure green colored bar. And the accuracy on the y-axis just goes from 40 to 90 here, just to show the range that these models actually reach. And the red horizontal lines are the accuracies that the pre-trained language model reached. And so you can sort of see immediately that no matter how these, how GPT-4o is prompted, it doesn't get the same accuracy as a pre-trained language model. But what we're doing is prompting with no example, showing here's an example student response and how you should treat it. And that would be an example for each one of the 3 classes. And then each next bar is adding another example. So we go all the way up to 5 examples. And then for the last 3 data sets, we use the rubric. And for iStudio and classifies, the rubric is very concept oriented. And so you can see that if we prompt the language model with the rubric, it actually uses the rubric and does much better than it does without the rubric. So that's shown here, that the concept-based rubrics provide the greatest boost. So how do we combine the 2? Well, we prompt GPT-4o Mini with the question, the rubric, the model response with the label, and the actual student response. And instead of using the human labels, we get a low-cost synthetic label from GPT-4o Mini. So then we wouldn't have to do all that expensive training of people or finding experts to label all that data. We just have GPT-4o Mini label the data. So now we train the PLM with this semi-synthetic data that's actual student responses, but synthetic labels. So it's much cheaper. And what happens? That's shown here on this slide that I will explain to you here. So again, the accuracy axis just goes from 40 to 90. And what it's showing on the y-axis is how much training data is provided. And the 2 lines are for classifies, the gold color, and iStudio, the orange color. And we see that this is a sensitivity plot that shows that the performance gets peaks with about 4,500 examples or so. And at that point, the pre-trained language model using the semi-synthetic data is performing as well as the large language model when it's prompted with the rubric. The stars represent where the pre-trained language models are for the 2 data sets. So you can see that we're still not getting as close to the pre-trained language model with the human data. But if we could get the large language model to label better, then that would solve that problem. And so that's one of the things we want to work on. So that's what the 2 stars show, is the accuracies from the pre-trained language model and the number of examples that were used for training the models. So I've already mentioned this point, and let me go to the summary, which is that for each of these methods, the PLM, the LLM, and the PLM-LLM partnership, I've got the same bullets. And the PLM gets the best accuracy, state-of-the-art, but doesn't utilize the rubric, needs thousands of training examples, and is domain-specific, so you'd have to train it again for a new domain. So in our summary, what we're trying to show is that we're essentially distilling the knowledge from the LLM when it's using the rubric back to the PLM so that we can train it without having the expense of these labels. Because the LLM, even though it underperforms the PLM, it does utilize the rubrics, doesn't need training examples, and it generalizes across domains. So you could just use this method for labeling the data for whatever your data is. And we get, by the partnership, closer to the state-of-the-art accuracy than the LLM alone. But it's actually about the same as the LLM with the rubrics. But we can use the smaller, lightweight model, and it utilizes concept-based rubrics, lower cost, generalizes across domains, and it has the potential to provide explanatory feedback to the students. I'm not talking about the explanatory feedback yet in this talk, because we've begun to look at that, and we've done some assessment of whether the explanations kind of align with the rubric. But what we want to do in the future, and what we're working on for a new proposal submission, is that for students to really assess for students whether a certain type of feedback is helpful, we need to look at how they perform after the feedback and give them a new task to do, or new judgments to make, and so on, because otherwise we don't really know how they're using the feedback. And so that's why I'm not talking about it here, but that's definitely something that we want to look into, because that's sort of what large language models are good at. They're very fluent, and they can generate feedback. So that is the conclusion of my talk. And let me stop sharing the screen. There we go.
Thank you, Becky. I think we have one question so far in chat from Everton has this work been published already?
No, it hasn't, but it's in submission.
Okay, awesome. Okay, so we are at time. Does anybody have any last minute questions for Dr. Passonneau before we conclude? Awesome. Well, thank you, Dr. Passonneau, for a fantastic presentation. I know I learned a couple things about assessments and AI, so I am curious to see more of your work when you publish, and interested in your next sort of submission you're doing with that too. So thank you to both of our presenters. If you have any questions for either of them, you can either reach out to me and I can make sure they get to them. I know Andy has put his email, so you can reach out to him specifically for any Nittany AI questions, ideas, partnerships. If you have any questions for Dr. Becky Passonneau, you can drop them in AI Horizons or reach out to her directly. As always, continue the conversation in AI Horizons, and the recording will be available later this afternoon in Teams. So thank you, everybody, and we'll see you next month for AI Week.